first thing that we will be doing is to fill up the containers with equal amount of water, enough to submerge the tomatoes. So we will be using the distilled water. We'll be putting it in the containers in equally the same amount. So now that these containers have equal amount of water, we'll be now starting our experiment. So in my container, the water is exactly 300 ml. If you can see, it's 300 ml for all the other containers as well. So in setup A, we're just going to submerge the tomato inside. So now that it is submerged, now we will go to setup B. In setup A, we just submerge the tomato in the container. However, I added water on the container to make sure that the tomato is really fully submerged. So instead of 300 ml of water, I added it until 450 ml. So I did the same step on the other containers as well. So that is for setup A. For setup B, we're going to add 2 tablespoons of salt into our container before we put the tomatoes in. So to avoid spillage of the content, I put a container on it. So we're going to put 2 tablespoons. So 1 and then 2. 2. And then we're gonna stir it until the solute, which is the salt, is fully submerged. Fully dissolved, sorry. Have to make sure that the salt is dissolved. So as you can see, there's no more salt on it, it's completely dissolved. So now that we have put the salt in the container and it's totally dissolved in water, we're going to submerge the tomatoes in. So setup B is also done. So this is what happened in setup B. We've already submerged the tomatoes in. After we have completed setup B, we're now gonna put 5 tablespoons of salt in setup C. So we'll be doing the same thing as what we did with setup B, but instead of 2 tablespoons, we're gonna make it 5. We have 1, 2, we have 3, 4, 5. Now we're gonna stir it until the salt will completely submerged. This time it's a lot harder to stir, and a lot harder, but now solute is not dissolved faster unlike setup B. So we can still see solute particles. So we're gonna continue stirring until it's completely dissolved. So I like using regular salt with bigger particles. It's much nicer to use salt with just more refined. It does it's a lot easier to dissolve in water. And even regular salt, bigger chunks of it can dissolve in water, but then Using refined salt is a lot easier to dissolve in water, so it makes the work faster as well. There are still a few particles, so let's continue stirring. I don't think there's any more particles. So the salt is completely dissolved now. So we'll stop stirring. So now we will also be putting the tomatoes in the container because the salt is already dissolved. So we're submerging it. So it's now submerged. So this is what happens in setup C. So as we can see, the tomatoes is already in and it's submerged in the solution. So now that we are finished with setup C, we're gonna do setup D as well. So instead of using salt, now we're going to use sugar. So we're gonna add 5 tablespoons of sugar in the container. So that's 1, that's 2, that's 3, and that's 4, and then that's 5. So we'll be doing the same thing. We're gonna stir the sugar so that we completely dissolve the water. I'm just going to be stirring. So you can still see a few particles, a few sugar particles. We're going to stir and stir and make sure there's no more particles left. I think that's finished. No more sugar particles in it. So the same as the salt, it's easier to use refined sugar. So it's easier to kind of like stir than having big chunks of sugar, which will take longer. So it's finished. Now that we have our solution and the sugar is completely dissolved in water, we're going to submerge our tomato in our container. So the same thing as what we did with the other 3 containers. So this is setup D. So the tomato is inside as well. So we will be observing the tomatoes inside this container for 5 days. Now that the tomatoes is submerged in different solution. So this is with water, with complete distilled water. Inside of the setup A. For setup B, we added 2 tablespoons of salt. And the tomato is also submerged. In setup C, we added 5 tablespoons of salt. The tomato is there. And lastly, in setup D, we added 5 tablespoons of sugar. So we'll be observing what will happen with the tomatoes for 5 days. And by then, we will be observing the phenomenon called osmosis and what osmotic pressure does to the processes in the tomatoes and in the water. So we'll see you in our second day of observation. So this is our first day of experiment. I will see you in the second day. Bye. Good morning, everyone. It is day 2 of our experiment. It's 6:30 in the morning. So once we see it on camera, especially in this angle, you might think there's really no changes at all. But let's go first with setup A. In setup A, there's really no changes with the tomatoes at all. The appearance is still the same. So there's really no changes with the container with distilled water. So when we submerge tomatoes in distilled water, we do not see any changes yet. So we will see it from the top view. So it's pretty much the same as when we put it inside the container. It's still of the same appearance. So if we remove it from the container, as I feel it, it's really still the same tomato as I put in the container. It's still kind of hard. It's not really swelling, nor is it shrinking. So there's really no changes yet. So that is for tomato in distilled water. So that is it for setup A. For setup B, so this is the top view. So if you see it from the bottom, we might think that there's no changes. As well as if we look at it from the top, so we might think like this is the same tomato that we put. However, if we remove it from the container, we could really feel that there's really water inside the tomato, because if you feel it, it's kind of shrinking. It is shrinking. It might not be very clear on camera, but there are wrinkles on it, and it is kind of shrinking already. If we feel it and if we touch it, it's very soft, really, unlike setup A when it's still kind of hard. So we can see really the difference with the tomato that we put before and after we put it in setup B. So yeah, this is tomato in setup B. Let's go with setup C. So in setup C, really the same thing. If you see it from this angle, you might think there's no changes, as well as if we look at this angle, we will think that there's no changes. But once we remove it from the container and feel it, this is shrinking much more than setup B. This is the container with 5 tablespoons of salt, and though it might not be very clear in the camera, but it is shrinking. In this part, we might see its wrinkles, those wrinkles on it. See, that part's very clear. See, you can see it. It's really shrinking. Though setup B is shrinking, but setup C is shrinking much more. So that is tomato in setup C. In setup D, we will look at it from the top. So we can see that the tomato still looks the same. But once we remove it from the container and feel
the third day observation. It's a third day. As you can see in the set A, it's fully drawn. The tomato is fully drawn. And in the set B, 3/4 of tomato is drawn in the water. And set C is also 3/4, but the water is high. B as well, much higher in the A, and C is much higher in the B, as well as the D is much higher in the both. This is the sugar. As what I observe in here is in sit up D is there is a presence of some hormigas, because it's a sweet liquid in there, and we're gonna get we try to get the big in the sit B, in sit A it's I think more oily, and I think nothing happened in sit A. It's just the day we put in the wet container in the sit B is more not oily, but more malleable sting, and as well as the third much more malleable in the B, like can compress, easy to compress. In sit up D, much more compressible or mapisa kaysa nila. Lata siya. It's all in sit up 3. That's all for third day of survival.
Hi everyone, this is the day 4 of our experiment. So today we will also observe if there are any improvements or changes in our experiment. So let's go. So as what I can see guys, setup C have a changes. It's like there are wrinkles in the tomato's body. They are forming of wrinkles, unlike A, B, and D. But I think the B and D will also forming wrinkles, so maybe we will observe it tomorrow or in the next day.
Hello, today is the 5th day, which is September 6th. Yeah, September 6th. Excuse me. There's no changes at all, unlike the other days, like the following days. I don't know what to say. Like the other days, like yesterday, there were drastic changes, but now like seems like no changes at all. Wait, instead of instead of D, like it turned yellowish. There are parts like I don't know if you can see it, but there are parts like yellow. Unlike yesterday, like it was really red. Today it's like there are yellow parts. Like so far, that's the update today. There's no changes at all. B, nope, still the same. Instead of A, still squishy. Like oh my god, it's so squishy. Like I can't. But so squishy. Yeah, that's all for today. And let's see if there are changes in the 6th day. Morning everyone, it's 10:30 in the morning and it is the 6th day of our observation. So we will first start again with setup A. So this is setup A, and again we will be looking at it from the top view. So there is the tomato in setup A. We will remove it from the container to see it better. So for setup A, there's really not much changes, though I can notice it's a little heavier. That's what I've noticed compared to yesterday. But in appearance, not much. There's no wrinkles or anything, so there's really no change, except for the fact that it's kind of heavy. So that is it for our setup A. We'll move on to setup B. So we'll look at it from the top view again. So this is setup B from the top view, and we'll be removing the tomatoes to see it better. But as you can notice, the water is also a little dirty. I think that is from the salt particles that were still there. So we will see. Compared to how it is yesterday, it is really soft now. Like really, you can literally put force on it and it's just gonna like break. Not break really, but like you can press on it and this is gonna like blow up. It's really soft now. Its wrinkles are a lot smaller though compared to setup C. See that? Those are the wrinkles. And it's a lot softer. See, if I press it down here, you can see I'm not adding much pressure, but you can see that I add more pressure to this, is gonna break really. Like literally, see that? There's really not much force. But see how fragile this is. So this is the tomato in setup B. So this is the tomato in setup C. So as you can compare with setup B. So there are bigger wrinkles, bigger crinkles in this tomato compared to setup B. If you touch it, it's also soft. But compared to setup B is really, really softer. It is really softer now. They still have parts that are hard, but at the same time it has wrinkles. And same as setup B, once I put pressure on this is gonna blow up. Literally. So that is it. See how deformed this tomato was. This tomato used to be really kind of like circular in shape, but now it is really deformed. See the wrinkles? Those evident wrinkles. There. More wrinkles on this side. So there are no wrinkles in the top side since the tomato is not completely submerged. I mean, the tomato keeps going up, so see that? It's really deformed now. It's like deflating, slowly dying. There. So mura siyang nalata in Visaya. So that is it for the tomato in setup C. So this is tomato in setup D. So I didn't show you the container, but it is setup D. So this is the container in setup D. It's kind of weird because now I do feel like it's kind of swelling at the bottom. It's not like this when I saw it yesterday, I guess. I don't think it is very evident in the camera, but for me, I really did think it's swollen. It is a little swollen now at the bottom part. It is a little swollen. So this tomato, same as setup A, didn't have much changes the previous days, but now I do think this is kind of swelling. Really, I don't know if it's very clear to you guys and if you can see the difference, but for me, when I see it personally, I was really kind of amazed how this swelled up. So that is it for setup D. So another great observation that I have noticed within this setup is that setup A feels like it's like finally submerging really deeply than the other setup. It's like going to fall already. So in other observation I have noticed from my group mates, their tomato really fell down. It's like kind of drowned in the solution. So in this kind of angle, you can see that while setup B, setup C, and setup D, they're kind of floating still. Setup A is still floating, but it's a lot lower. And to imagine that this has equal amounts of water when I first put it, it's 450 ml, and now it feels like the water in setup A is like slowly being absorbed. So it used to be 450 ml, but now it's like half 450 ml. It's not 450 ml anymore. So compared to setup B, setup C, and setup D, in setup A, like the water is being absorbed. And maybe that is why the tomato's weight also increased because of the absorption of water. And that is all for my observation in setup A. So with our observation in 4 to 5 days of observing what happens to a tomato submerged in different solutions in our different setups. In setup A, we're gonna review. In setup A, we have a solution of just pure distilled water. In setup B, we have a solution of 450 ml of water, 2 tablespoons of salt. In setup C, we have also 450 ml of water and as well as 5 tablespoons of salt. In setup D, we have 450 ml of water and 5 tablespoons of sugar. So in conclusion, the phenomena or the process that we are actually observing all throughout the days is what we called osmosis. So osmosis is a process by which molecules of a solvent tend to pass through a semi-permeable membrane from a less concentrated solution into a more concentrated one, thus equalizing the concentrations on each side of the membrane. So that is the reason why some of our tomatoes kind of swelled up, or the others kind of like shrank or something, or created wrinkles, it is because of the process called osmosis. So we all know the tomato is made up of tiny living units called cells. Each cell is surrounded by a cell membrane which acts as much as our skin does. It keeps the cell's parts inside and keeps other things outside, protecting the cell. While this membrane stops most things, water can pass through it. And by definition of osmosis, it is the movement of water through a semi-permeable membrane from a region of a higher water concentration to a region of a lower water concentration. So, we have also noticed that despite being able to put the same amount of solutes, example, in setup C, we have 5 tablespoons of salt. In table D, we have 5 tablespoons of sugar. So they are of the same amount of solute and same amount of solvent, 450 ml of water. However, they do not exactly have the same result to the tomato itself. So we can see the differences of our observation on the table, which will be presented later on. So the water tends to move towards higher concentration of dissolved chemicals. That means that if the water outside the cell is saltier than the water inside, water will move from the inside of the cell to the outside. So that is what happened to the tomato in the salt water. As the water left the cell, it was much like letting out of air in a balloon. So as more and more of the cells lost water, the tomato becomes soft and flexible, thus creating wrinkles. The same thing happened to the sugar, but since the cells in the tomato contain more sugar than they do salt, the cells did not get as soft, and in our case, the tomato swelled up in setup D. In setup A, where there is only complete and pure distilled water, the reverse happened. Water moved from outside, where there was no salt and sugar, to the cell where there was salt and sugar. So this is the reason why the tomato kind of like stiffened up and something. So that is it for our observation, and I hope you learned so much about osmosis. And if you want to see it for yourself, you can try experimenting it for yourselves as well. And there will be guide questions that we will be answering in case you have more problems in relation to osmosis. So that will be all for our experiment. Bye!